This video shows how to adjust the parameters of the laser profiler after hardware setup to obtain qualified data. The laser profiler parameter settings in Mech-Eye Viewer are divided into profile mode and scan mode. The two work together to generate intensity images, depth maps, and point clouds of target objects. In profile mode, the laser profiler scans specific positions of the target object. This ensures the image quality of a single profile and provides essential data support for subsequent scans. In scan mode, the laser profiler, based on the imaging results from profile mode, stitches multiple profiles into a complete intensity image, depth map, and point cloud. Therefore, the quality of the profiles determines the quality of the intensity image, depth map, and point cloud. For this, when adjusting parameters, first ensure complete data extraction in profile mode, then configure the parameters in scan mode. This video will demonstrate the parameter adjustment process by measuring the connector pin height. The objective is to measure the distance from the pin tips to the surface of the PCB board. Next, let's proceed with the basic process. First, create or select a parameter group. During the subsequent pin height measurement process, the group will be used by the measurement project to collect image data of the pins. Then, open the profile mode to adjust parameters. Ensure the raw image is complete and features appropriate brightness. The profiles of the pin tips and the PCB board surface should be smooth and complete. This will provide a foundation for subsequent image data in scan mode. Once the profiles meet the requirements, switch to the scan mode to adjust additional parameters. Ensure that the image data of the target regions is complete. Finally, save the parameters. Now let's begin the detailed operational steps. Open Mech-Eye Viewer. Select the laser profiler to be connected. Open the IP configuration dialog box. Make sure the IP address of the laser profiler is on the same subnet as that of the IPC. Click Apply. Then, connect to the laser profiler. In the Parameter Group section, click the Add button to create a parameter group. Enter the parameter group name and select the corresponding template. Here, simply choose Default. Next, switch to Profile mode and begin adjusting the parameters. Click Capture once to check the position of the profiles at the pin tips. It's evident that the profiles are not positioned at the reference distance of the sensor head. Typically, the data quality is better at the reference distance. Thus, during continuous data acquisition, adjust the height of the sensor head until the profiles are close to the reference distance. Then, fix the sensor head. Afterward, adjust the parameters based on the effect of the image data. The current profiles are complete but lack smoothness, with a few noises present in the target region. Since the profiles are composed of the blue spots in the raw image, adjustments to the parameters can take the raw image effect into consideration. The blue spots are extracted based on brightness. Thus, it's necessary to adjust the brightness settings. The pixel values from the exposure information can be referenced when adjusting the brightness. Ensure that the brightness of the raw image is appropriate. This means there should be no significant lack of spots in the target region, and the center of the laser line should not contain too many pixels with a grayscale value of 255. In this scenario, the brightness of the raw image already meets the requirements, so no further adjustment is needed. Then, set the region of interest. Setting the ROI in the XZ plane can reduce the amount of data to be processed and enhance the max scan rate. Please note that the profiles of the pin tips and the PCB board surface should be within the ROI. Next, adjust the parameters related to profile extraction. Return to the raw image. During the process of parameter adjustment, maintain complete profiles by ensuring no spots are missing, and avoid any blue spots in the target region. Set visibility to expert. For profile extraction, the min grayscale value parameter can be adjusted to exclude the pixels that are too dark in the raw image. Pixels with grayscale values smaller than this value will not participate in profile extraction. In the lower right corner of the raw image, check the grayscale value of the pixel where the cursor is located. The minimum grayscale value should be set based on the grayscale values of the noises in the image. At this point, most of the noises have been removed, and there are no missing spots at the pin tips. Continue to process the profiles to make them as smooth as possible. Set the filter as mean, and adjust mean filter window size based on the effect of the profiles. Larger window size enhances smoothing intensity, but may also distort object features. Finally, set masks. By adding the masks, data from non-critical target regions can be blocked or ignored. Click Apply. These are all the steps for the parameter adjustment in profile mode. After the adjustment, the brightness of the raw image is proper. The profiles of the pin tips and the PCB board surface are complete and smooth. In addition, there are no noises in the target regions. Now, switch to scan mode to adjust relevant parameters. To obtain complete image data in scan mode, it's necessary to configure trigger settings and scan settings first. In this scenario, the triggering method for data acquisition is the combination of external plus encoder. The external device to trigger data acquisition is a photoelectric sensor, and the encoder is installed on a motion platform. However, to make it easier to check the effect of the parameter adjustment, select the data acquisition trigger source as software first. When the parameter configuration is complete, set the parameter back to external. Then, configure the encoder settings. In this video, use the encoder settings tool to complete the configuration. This tool is used to check the encoder value, obtain the motion direction, and calculate the encoder resolution. Based on the resolution and the trigger signal counting mode, the tool can also automatically calculate the recommended trigger interval. Since the resolution of the encoder is unknown in this scenario, choose Calculate Resolution. Considering the encoder motion direction, set trigger direction appropriately. This can be selected as required. In this scenario, select both. Next, calculate the encoder resolution. First, update the start value. Then, move the motion platform a certain distance. The distance set for this scenario is 50 mm. After this, update the end value. Enter the distance value into travel distance. Click Calculate to obtain the result of the encoder resolution. Then, configure trigger signal counting mode to obtain recommended trigger interval. The two together determine the rate at which scanning is triggered. In the scenario of connector pin height measurement, the aspect ratio of the target object in the image data should match that of the actual object. This means that the y-axis resolution and x-axis resolution of the intensity image and depth map should be 1:1. This video uses the Lynx 8030 model for demonstration. Its x-axis resolution is 9 micrometers, so the y-axis resolution should also be 9 micrometers. The encoder resolution is known to be 1 micrometer. Based on the above calculation formula, it can be seen that when the trigger signal counting mode changes, the tool calculates different trigger intervals. This results in different counts at which scanning is triggered. When the counting mode is set to 4 times, and the trigger interval is calculated to be 9, it ensures that complete image data is obtained within each signal cycle. This more accurately reflects the actual shape characteristics of the target object. Click Apply. Next, set the scan line count to ensure completeness of the acquired image data. Use the formula to set the parameter. In this scenario, the length of the object is 12 mm, and the y-axis resolution is 9 micrometers, so the result is 1334. To ensure that complete image data is acquired, the set value should be slightly greater than the calculated value. Thus, keep the default setting here. Acquire the image data to check the aspect ratio of the target object and the completeness of the data. As shown, the data in both the intensity image and the depth map are complete, and the aspect ratio of the target object is qualified. In addition, there is no problem with the point cloud of the target regions. At this point, no other parameters need to be adjusted. Switch data acquisition trigger source from software to external. Verify the parameter adjustment effect with the photoelectric sensor. Check the quality of the image data again. After verification, save the parameter group. During the subsequent pin height measurement process, the parameter group will be used by the measurement project to collect image data. Now, the parameter adjustment for the laser profiler is complete. You can refer to our documentation for more details on the profiler parameter adjustment.